All right. So, ladies and gentlemen, we want to begin our lecture for today. And this is the way I want to go about it. We have the Brukutu venture data. This is the Brukutu data set that we have been dealing with all these while. And this data set, we have been using it. What we want to do is to reload them and get the information so that we will interpret them as from the last one that we did. Okay, so we're going to interpret them. So what I'm going to do is I'm going to send this information back to R by copying the entire data set and taking it to R. So I go to my R section there, and then in case I've not loaded the data, you load the data. I want to check the data down there, and under down section, you will have in the control panel, in the console, you see the data has been loaded down here, okay, in the control section. All right. So at this stage, what we want to do is that we're able to upload some library called JTools, okay, some package called JTools. So I just want to do that again quickly, okay, JTools that we did. And then we ran the data, which was gene multi, okay. I'm quite sure that most of you will remember the use of the, gene multi. And gene multi was the actual original name of the data that we had. Okay, that was a very original name of the data that we had. So this is gene multi, which is equal to LM kill tilde sign plus P plus C plus M plus loc, that is location, plus occupation, and then religion. Okay, so that was it. That was the information that we had there. I'm going to run that, look down here with a summary, and then you'll get the results, okay, showing down there in the console. So those were the results. And with the JTools command, the good thing is that we're able to see the model information. The observation number, which was 40, the dependent variable is quantity demanded of gene vectors, the type of regression is OLS regression, the fitness of the model, which is defined by the R square. We'll talk about that briefly. It's all here. And then the p-value for the f-test. Okay, that was also 0. We'll talk about that pretty soon. In fact, we did the other time. Okay. We indicated that there was another model that we can generate. Okay, and I'm talking about this command that I've highlighted here. And that model was just to run the whole thing without the constant. So just doing that without a constant, it will not bring the constant, the intercept, which is what you see there. And then we indicated that we can report robust standard errors, okay? And we indicated there are multiple types of robust standard errors, but we shall use the HC one. When we get to heteroscedasticity, corrections, we will talk about all this. So we run one robust standard errors, and we click on it and show the results, and that is the results. Again, when you look at it, okay, it will tell you the type of the regressions. And you can see that in all of them, the type of regression is being shown as OLS regression. But when you come to the last one, the robust standard errors, it will tell you that standard errors robust type HC1. So it's able to showcase. And then we even generated a GLM, okay, generalized linear model and RMS model with a command, which is this. And with this, we were now able to put everything into a beautiful table. Okay, we're able to put everything into a beautiful table by using the Hugs table package. So we commandeered the Hugs table package, and then we exported our results. Okay, and we got this beautiful, results with 4 different models. Okay, that we had. And our goal was to interpret the results. So let me take you back to our slides. And this is the table that we had. Now you got to understand that the first one that we have here, the model one, is our original model. And the good thing about this table is that it's able to give you the key information that one needs. The R square, the archaic information, the BIC, the pseudo R square, all of these things will be needed at the proper time. But the key one you need is the R square. Okay. Now this table is slightly different from the original table that we had. Now what do I mean by the original table that we had? Okay. Well, if you check, this is original table. If we had not used the library J tools. But this is the original table. And the key is to interpret the results. Okay. We've been able to determine the significance of the results, the R squared, adjusted R squared. We've explained all of this in the previous videos. Okay. We've even determined the joint significance. We looked at the partial significance, which is the independent variable, then the joint significance, okay, which is the F test and the p-value for the F test, where we indicated that if it is less than 5%, it means all the coefficients are jointly significant in determining the dependent variable. We realized that the R square here was 99%, which shows that 99% of the variability in the quantity demanded of gene bitters has been fully explained by the entire regression line or by all the independent variables. So we dealt with that. Now, today what we want to look at is how to interpret the coefficient. How to interpret the coefficient. So interpret each coefficient starting with price. Okay. Now, first, let's go back here and then look at the price coefficient. And we are going to focus on the first model. If you look at the coefficient for price, it is minus 5.31. Minus 5.7. Minus 5.7. What does this mean? How will you interpret this? Okay. Now, in most papers and most theses, the way you interpret this is that, of course, you have to hold all other factors constant, and those are the other independent variables. So you start by saying that on average, and because regression is an average, okay? So on average, given all the independent variables, but I always advise that if you can, in a kind of exam situation, in a learning environment, not in a thesis or journal paper writing environment, you will mention all the independent variables, okay? So I will interpret this price of gene bitters as, on average, given the complement price of gene, the income of the people, okay? Given the complement price of gene, the income of the people. Let me just go and then use some of these notations so that you see, okay? On average, given the complement price of gene, the income of the people, the location of the shop, the occupation of the people. So in terms of occupation, I'm not going to talk about occupation teaching and occupation trading, but you just put all together and say occupation. So the occupation of the people and the religion of the people, okay? So given all of this, okay, a 1 unit increase in the price of gin, and I'm now interpreting the value, a 1 unit increase in the price of gin reduces the quantity demanded of gin by 5.7 units. Okay, a 1 unit increase in the price of gin reduces the quantity demanded of gin by 5.7 units. That is if you are using this value here. Now, why reduces? It reduces because of the negative sign in front of the 5.7. So that is how you interpret. This is an example of a numerical variable, a dynamic variable. Okay, this variable is not static. It's not a dummy variable. It's a dynamic variable. Okay, it's not static. And so when you are interpreting it, it's a very, very important way. Now that is how we did it. But in the actual formulation that we had, in the actual formulation, if you look at it here, the value was not negative 5.7. It was what? Negative 3.15. And so if you are interpreting it, wherever you say 5.7, you will use 3.15. Now, let me show you how you interpret complement price. Remember, complement price too changes. It's a dynamic variable. So when you are interpreting, you've got to interpret it as on average, given the price of gin. You see, now I have to go to the price of gin. But you don't say given complement price of gin because that's the one you are interpreting. So you say given the price of gin, the income of the people, the location of the shop, the occupation and religion of the people. Okay. A 1 unit increase in the complement price of gin will reduce the quantity demanded of gin by 0.11 units. 0.11 units. I say 0.11 because I've rounded it up to 2 decimal places. I say reduces because of the minus. So that is how you interpret these variables. But it's different from the way you interpret static variables, dummy variables, categorical variables, binary, okay, variables. Because these variables are not increasing, they are static. For example, the location is either urban or rural. It's not rising from urban to rural or from rural to urban. Neither is a person's religion rising from Christian. Okay? At least within a time period of a year, a person is not changing the religion up and down every year. And so the way you interpret these are slightly different from the way you interpret the dynamic variable. These are static. So I'm going to interpret the location. And watch it. You notice that anytime they are bringing the dummy variables, the reference category is not added. Okay, they don't add the reference category. So the reference category must be at the back of your mind when you are interpreting that. Of course, after the interpretation, you can always say that, and it is significant at this level of, based on the number of stars, which we have also explained that in a previous model. So we interpret the location urban. On average, given the price of gin and the complement price of gin, the income of the people, the occupation and religion of the people, okay, quantity demanded of gin is expected to be, or is predicted to be, quantity demanded of gin is expected to be 5.11 units less if the people are located in an urban than rural area. If the people are located in an urban than rural area. Now, why less? Less because it is minus. Otherwise, I would have said quantity demanded is expected to be 5.11 units more if it was plus. But you see, I said less than rural. So rural is not here, but I'm comparing it to rural because I know that the reference category was rural. And I'm always comparing the urban with the rural. So before you actually do the comparison, you must know what a reference, the base category is. And you can see that I didn't say 1 unit increase, no, because urban is not increasing. But I rather said quantity demanded is going to be, it's predicted to be, it's expected to be this or that, if the people are that or than that. And you can say that, however, this is not significant. Okay. And the reason why you can say, however, this is not significant because the p-value for that coefficient is almost 19%. It's above 5%. Now let me interpret the religion Muslim. Okay, the religion Muslim. And again, before I interpret it, I must know the reference category. We have Christian, we have Muslim. What is the reference category? That is Buddhist. So I must have that at the back of my mind. If I was interpreting religion occupation, we have teaching here, we have teaching, and then we have, what do you call it? We have trading. Okay, we have teaching and trading there. And so because we have teaching and trading, I should be able to remember. Okay, let me just talk about these two. Okay, I'm just talking about these two. We have teaching and then we have trading. No, not this one. Okay, we have teaching and then trading. And the reference category is what? You must remember that that is fishing. Okay, that is fishing. You must have that at the back of the mind. Okay. Now, what I'm going to interpret now is religion. And like I've already said, this one, religion, the reference category is Buddhist. So I must have that at the back of my mind before I start my interpretation. So I'm going to do religion Muslim. Okay, religion Muslim. That's what I'm going to interpret right here. So keep that in mind. It's religion Muslim that I'm going to talk about, this very one. Okay. So how do you do that? How do you interpret religion Muslim? The value is negative 23.00 or negative 23.01. Well, this is how you interpret that value. Okay, and I'm going to interpret it the way it's got to be. On average, given the price and complement price of gin, income of the people, location of the shop, and occupation of the people. You see, I didn't say religion. And occupation of the people. Quantity demanded is predicted to be 23.01 units less if the people are Muslims than Buddhists. If the people are Muslims than Buddhists. You got to master how to interpret the dummy variable. It's very important. Okay? And this is significant at 0.1%. And this is significant at 0.1%, which is what you can see here. Okay. It's significant at 0.1% because of the 3 stars. So that is how you interpret. Okay. If you in the process, the interpretation. So that is how you do an interpretation of all of these particular independent variables. I want to address one particular question for the purpose of this study. Sometimes you get a question of, and this is if it was in a classroom situation, you get a question of specifying a regression model, like this, specifying Brukutu cross-sectional regression model. Okay. So this is a model, and ideally, you must have specified this model before you run the estimated regression. Okay. And when you are specifying the model, the variable, and this is what you put into your thesis or your journals, okay, ahead of time before you even run the model. And the way the variables have been defined here, that is what is going to guide you in specifying the regression model. Okay. So what I mean is that when you look on the coefficients here, the names of the coefficients, when you look at the names of this coefficient, the same names are what you're going to use to do your specification of the model. If it was an exam situation or it was in a classroom situation. But if it was in a journal paper, maybe the names are so long, so you have to use a different names. But I'm going to just treat it like if it was in a classroom situation. That one, you have to just write it the way it is. So how do you specify the model? Well, the R has already done it for you. If you look up there, R, the formula, core formula, has already done it for you. And you can see that, you know, right here. So when you look up there, okay, when you look up here, you will see that the core formula has actually done the work right here for you. Okay, so what you have to do is to just give it as it is there, just as it is there. But of course, you have to make some few changes by bringing what? The beta parameters. Because normally, a dependent variable is the one that comes first here. So you have to bring beta naught and then P. a beta naught, which is a constant. Before you do plus beta 1, P, plus beta 2, C, plus beta 3, M. But here you got to be careful in this second scenario. In this second scenario here, you have to be careful because even though it is, the call is giving you the total grouping, the categories. And so you have to come down to the actual, the actual solution. And in the actual solution, you will do the breakdown properly for you. And so this is the breakdown you have to rather use. Okay, location, urban. Okay, so you have to have beta 4, okay, lock urban, plus beta 5, occultation, plus beta 6, occult trading, plus beta 7, real Christians, plus beta 8, real Muslims. And then you don't forget to add your error time, okay, as it's supposed to be in that regard. So this is an important thing, So I want to just show you how it is supposed to be done, okay? But just note that you understand how it works here before. So you can see that this is where the formulation is actually properly done. And you can see that this is a formulated, a specified regression model that we have indicated. The error term has been well incorporated, okay? The error term has been well incorporated in the analysis, in the story, right there. So it's very important to appreciate that. And they are dependent. I have brought I for each one of them to indicate that this is a cross-sectional model. It's not a panel model. Okay, of course, you later learn about panel model. The estimated regression equation. Okay, this is a classroom situation. If it was an estimated regression equation, you just go and take the coefficients and replace each coefficient, replace each beta parameter by the coefficient. So when we go up here, each of these estimates, the numbers will replace the various, coefficients that are there. Okay. So if you pick on each one of these, okay, the numbers must be documented when you are writing the coefficient. So when you come to writing the coefficient, okay, if you look at the intercept, it is 280.27. Okay. And so that's what you're going to write for this value. So you rewrite the whole thing, and then you write 280, okay, 0.27. And then the rest will continue for each beta parameter, changing it with the estimate. By remembering that the estimate, if it has a plus in front of it, bring plus. For example, the last one, Christians, religion Christians, was plus 55.55. And when you go to the data set, you see that that one was plus. Okay, that was plus. Even though the others were not plus, that one was truly a plus. And then once you've indicated that, this becomes your estimated regression equation. It's very important to understand that in a classroom setting. Okay, so that is it.